This video is on solving linear inequalities. So basically, you'll notice that this looks just like y equals mx plus b, except instead of an equal sign, we have a greater than sign. So if you think about y equals mx plus b, or if this were an equation, it would be y equals negative 1/5 x minus 4. There are infinitely many solutions that make this statement true. Every point on this line makes this statement true. Let's think about it. We start at negative 4 on the y-axis, and we go down 1 over 5, and I can only fit one point this way, so I'm going to go up 1 into the left 5 so that I can have 2 points to connect and draw my line. Of course, I would use a ruler. I should get a ruler. So, I have 3 points right now that make this statement true. Let's think about negative 5, negative 3. Point negative 5, negative 3. If I put in negative 3 for y, and negative 5 for x, and I do the math, negative 1/5 times negative 5 is 1, 1 minus 4 is negative 3. This point makes this equation true. So does every point on this line, from negative infinity to positive infinity. The difference when we have an inequality is that not only do the points on the line make the inequality true, but all the points on one side or on the other side of the line make the inequality true. I'd like you to pick a point somewhere up here, any point at all. Let's say 4, 0. Let's look at the point 4, 0. Plug in 0 for y and 4 for x here. And what you would get is 0 is greater than negative 1/5 times 4 minus 4. 0 is greater than, well, this is negative 4/5 minus 4. I don't even care what that is. I know it's negative, right? Negative 4/5 minus 4 is negative. 0 is greater than a negative number. Well, that requires you to understand a little vocabulary. Here's 0. Here's all the negative numbers. Is 0 bigger than all of these numbers? Yes, it is. This point makes this inequality true. Find a point down here, any point at all. How about 0, negative 6? See how that's underneath the line? Let's check the point 0, negative 6. I'm going to plug it into this inequality. Negative 6 is greater than negative 1/5 times 0 minus 4. Negative 6 is greater than. Negative 1/5 times 0 is 0 minus 4. Is negative 6 greater than negative 4? Think about a number line. Negative 6 is here, negative 4 is here. Negative 6 is not greater than negative 4. So this point is false in this inequality. That will always happen. All the points on one side of the inequality will make it true, and all the points on the other side of the inequality will make it false. The way we show that mathematically is to draw lines like this on one side or the other. There's one other little problem with this particular example. Remember how I said that this point, negative 5, negative 3, right here, made this equation true? And I plugged it in and I showed that negative 3 equals negative 3. Well, think about if I went through and did that exact same point again, but instead of having an equal sign here, I have a greater than sign. So now this would say negative 3 is greater than negative 3. Is that true? No, negative 3 is not greater than negative 3. It's equal to it. So in this case, all the points on this line do not make this inequality true. So whenever we have a greater than sign or a less than sign without the symbol underneath, I'm not talking about this, I'm talking about this, we have to draw a dotted line. Now I made a cardinal math mistake here and drew it in pen. If I had drawn it in pencil, I would go through and erase little points along the line. But I need to show my reader, or whoever looks at this graph, that the points on the line do not make the inequality true. So I draw little dots to say, listen, all the points up here make this inequality true, but the points on the line do not make this inequality true. Let's try this one. Again, it's already in y equals mx plus b form, so we're just going to start at positive 2, and we can't go up 7 and right 3, so we're going to go down 7 and left 3. Remember, it's the same thing. Up and to the right is the same as down and to the left. This time I'm going to use a ruler because I'm being a good math student. Except my camera's in the way. I used a ruler and I still didn't go through the lines. But anyway. So this time if I pick a point on the line, for instance 0, 2, let's look at the point 0, 2, and I put in 2 for y and 0 for x, I get 2 is greater than or equal to 2. Is 2 greater than or equal to 2? Well, you have to understand the word or. 2 is not greater than 2, but 2 is equal to 2. And this symbol says greater than or equal to. So this is a true statement. So that all the points on this line make this inequality true. In addition, all the points on either this side or this side of the line will also make this inequality true. We just have to decide, is it all the points over here or is it all the points over here? Now, in general, most teachers teach you to use the point 0, 0. The reason is it's really easy to plug in 0 for y and 0 for x. So I would like you to do that. Use the point 0, 0. 0 is greater than 7/3 times 0 plus 2. 0 is greater than or equal to. 7/3 times 0 is 0, plus 2 is 2. Now here's where you have to understand the vocabulary. 0 is greater than or equal to 2. Is that true? No, 0 is not greater than or equal to 2. 0 is less than 2. So this point on the right-hand side of the line is false, which means all the points on the left-hand side of the line will be true. Let's check one. How about -2, 4? The point -2, 4 should make this inequality true if I did it right. So I'm going to put in 4 for y, -2 for x. That's -14/3 plus 2. If you check that on the calculator, you will see that that's -8/3. And 4 is obviously greater than something that's negative. So it is a true statement. I shaded the right way. Okay. Let's just review. X is greater than or equal to -3 is a vertical line where x is -3. And all the x's that are bigger than it are this way. Now let's do one where we have to solve for y. Let's look at number 8. I can't graph that line right now because it's not in y equals mx plus b form. So I need to minus 4x from both sides. Right? I did minus 4x, divide by 5. So I start at -3. I go down 4. 1, 2, 3, 4. Of course, I can't do it, so I have to go up 1, 2, 3, 4 to the left. 1, 2, 3, 4, 5. I have a solid line because it has a line underneath. That means it's solid. And I have to check all the points on one side or the other. So I'm going to plug in 0, 0. I could plug it in here or here. Either way, if it's true, I shade towards it. If it's false, I shade away from it. So I'm going to do 4 times 0 plus 5 times 0 is greater than or equal to -15. 0 is greater than or equal to -15. Well, 0 is greater than -15, so this is true. Let's check this one just for the fun of it. 0 is greater than or equal to -4/5 times 0 minus 3. 0 is greater than or equal to 0 minus 3, which is -3. Also true. This point is true, which means all the points on this side of the line are true. All right, last one. Now, we need it in y equals mx plus b form. So most of you would probably subtract your 8x. And so you'd have -8x plus 15. And then you divide by -5. Hopefully you recall that when you divide by a negative coefficient, you flip over the sign. So this becomes greater than 8/5 x minus 3. So I go up 8 over 3, over 5. I'm going to draw a dotted line because it's this symbol and not the symbol with the line underneath. So a dotted line looks like this. I'm going to check the point 0, 0. I'll plug it in right here. 0 is greater than 8/5 times 0 minus 3. 0 is greater than -3. That is true. So I'm going to include this point in my shading, and I'm done. Why didn't that stop recording?